What's up, everybody? Welcome to 8.6 and 8.5. I haven't finished 8.5 yet, so I'm going to do 8.5 as well as 8.6. So we have our two remaining graphs that we haven't finished yet, and if you recall that the graph of tan x is it's like a bunch of like noodles falling, right? It's something like that, right? That's the graph of tan x. Let me draw a coordinate axis so it looks better. It's something like that, right? There you go. With asymptotes every pi over 2 iterations. So what's the graph of tan negative x? Well, negative x, if we put negative x in a function, just any old function, f of x, if you put f of negative x in it, it will reflect upon the y-axis. So we have this y-axis right here. And then the 2, what does the 2 do? Well, the 2 literally just makes it more stretchy by 2, right? So I'm trying to illustrate that it's more stretchy vertically by 2, but I don't think it's working. It's something like that, right? Something like that. So that's the function. Oh god, no. That's wrong. It's a reflection upon the x-axis. So it's like this, right? It's like this, and then it's obviously it's a 2 times vertical shift. So it looks like this, right? It still looks like a bunch of falling noodles, just on the other way. Next is minus 2 cosine pi x minus 5. So the cosine function, the cosine function is pretty similar to the sine function. If you want to know what the cosine function is different from the sine function, you could just know that the sine function is 0 at 0 and goes up and down like this, right? That's the sine function. And then the cosine function stays up here and then goes down and up and down and up. So the sine function starts from 0 and goes up first, and the cosine function goes straight down, right? And if you put 90 on the sine function, you will get the cosine function. If you shift the sine function back by 90, so it would be sine minus pi over 2, right? Or sine plus pi over 2. Wait, no, sine minus pi over 2. Wait, no, sine plus pi over 2. Anyway, minus 2, we have our period. The period is weird this time. The period is actually 2 pi over pi, which is 2. So the period is 2 this time, instead of a multiple of pi, which is a little weird, right? So let's have our 2 right here. Let's have our 4 right here. It is a cosine, so it's supposed to go up here and then it goes down, but it doesn't because it's negative, so it goes down then goes up, right? Because it's a reflection across the x-axis. The negative gives it that property. And what's even weirder is it's minus 5. Yeah, I'm sorry, this is really bad. There's supposed to be parentheses right here to stop the confusion. If it's minus 5, like a downshift minus 5, or a right shift minus 5, so it's shifted minus 5, so the graph will be something like this, right? And then in this side it'll look like this. Okay, this is a really bad drawing for that. Yeah, it'll actually look like this. Right, that's how the graph will look like. It doesn't look this smooth. It'll look something like this. Yeah, that's how the graph will look like. That's about how the graph will look like. So the next problem is modeling, and that's where the 8.6 starts. It's just all the modeling problems. So you're riding this Ferris wheel for 180 turn for 180 seconds, right? And your height in feet above the ground at any time in t seconds can be modeled by this equation right here. So obviously when you get in the Ferris wheel and then you turn, yeah. So this Ferris wheel turns over 180 seconds, and that's the function. Let's write the function down. 85 equals sine of pi over 20 multiplied by t minus 10 plus 90, right? So we can actually distribute this pi over 20 to the t and to the minus 10. This is a really weird way to write a function. Do not write a function this way. I don't suggest writing a function this way. 85 sine t again. So you'll have 85 sine pi over 20t minus 1 pi over 2 minus 10 pi over 20, and then all of this is added to 90. So since it's added to 90, we already know that our center of the graph is going to be at 90. Let's draw this graph. There won't be a negative axis on either axes, so we can just assume it's like this, right? And it's at 90. So the middle point is 90, and this amplitude is 85, right? The amplitude's right at the beginning, the vertical stretch basically. Normally it would go up 91, 89, 91, 89. Since we set it at 85, it goes all the way up to 90 plus 85, which is 175, and it goes all the way down to 90 minus 85, which is a really low amount. It's 5, right? So you'll be pretty much cruising the ground, 5 feet. I'm taller than 5 feet. Anyways, so that's our 85 and that's our 92 here. This minus pi over 2, what does minus pi over 2 do to a sine function? Well, this is a sine function. This is a sine function right here. And it's shifted right pi over 2. So if we shift this pi over 2 function right, it'll actually make it a negative cosine function, right? So we have this function. We shift it right. It'll look something like this new function like this, right? So this is actually negative cosine of pi over 20t. It's just negative cosine pi over 20t. No pi over 2. Right. So but how many times does it go? How many times does the revolution? How many times is there a revolution, right? And the answer is, well, pi over 20t is the coefficient pi over 20. So in order, we have to find a period in order to determine how many times this Ferris wheel spins. So 2 pi over 20, right, is equal to, if we go back to a few slides ago, I think I have the formula. Where is it? Amount of times it takes to go through one cycle, I don't have the formula, but it's 2 pi over 20, which is equal to 40, right? So every 40 seconds, it'll go, the Ferris wheel will arrive. So if you ask me, this is kind of a sketchy Ferris wheel, since it leaves you at the top after 180 seconds, which is a little weird. But the amount of cycles that this Ferris wheel makes in 180 seconds, 4.5, right? And graph the function, well, I kind of already did, but let me just finish off the function. It's like that, right? Oh god, that's really bad. It's like that. And what's the maximum minimum height? Well, I already figured that out as well. It is 5. It's the 5 feet is the lowest, so you're cruising on the ground, and 175 feet is pretty scary, and you're up there, right? So problem solving. The low tide at a port is 3.5 feet and occurs at midnight. After 6 hours is at high tide, which is 16.5 feet. and write a sinusoidal model. So a sinusoidal model just means a graph, or like a function that gives the height depth d in feet as a function of time t in hours. So let t equals 0 versus midnight. So we have our midnight at t equals 0, right? So this is t equals 0 right here, this line right here, right? And what's our depth? Our depth is 3.5 feet. So let's put 3.5 down here. And 6 hours, so t equals 6. So this is t in hours. After t equals 6, it will reach right here, which is 16.5. So we can already figure out what the middle of the function is. It's just the average of the two, kind of heights. The lowest height and the highest height, which is the middle height. The middle height is 10 feet, right? So 10 feet. And with this average, we can just determine many things. We can determine the height of the function. So this function is d of t is equal to whatever. What's the height of the function? What's it called? It's called the amplitude of the function. The amplitude of the function is the distance from the center of the function to the top or the bottom, and that's 10 minus 16.5. Absolute value of that is 6.5. So it'll be 6.5. But what does this look like? Well, if you go back one slide, it kind of looks like this function, right? It starts from the bottom and it moves up. So this function also starts from the bottom and moves up, which means it is a negative cosine. So it'll be negative cosine 6.5, a negative 6.5 cosine of whatever, right? And since, oh god, I can't write this as. And since it's a nice function, we don't actually have any right shift or left shift, right? We could say 6.5 sine and then minus pi over 2 at the end, but that's just, no, you don't do that. Okay, so what's the period though? So let's draw the rest of this function, right? It looks something like that. What's the period? So after 6 hours, it's at top, but after 12 hours, it's right at the bottom again. So bottom, the distances between bottoms or tops or middles, or two middles, right? So you take a middle and then you skip a middle and then you take another middle, is 12 hours. So that's our period, right? And in order to have our like our actual period, it will be 12 is equal to 2 pi over whatever down here is, right? We have to have something down here, right? So let's just say x. So now we can actually move it up, and we can do x is equal to 2 pi over 12. Because simple algebra, you can figure out that x is equal to 2 pi over 12, right? You multiply the 12, no, you don't multiply the 12. You multiply the x on both sides, you divide by 12 on both sides, and then you have x is equal to pi over 6. So you can actually just do 2 pi over whatever and figure out the period the same way that you would figure out the period just from the graph. So x is equal to pi over 6. So we have our pi over 6, and then we have our t. And then what's the graph? What's the vertical shift of the graph? Vertical shift of the graph is just shift 10 up. So it will be plus 10. And that is our function right there. And all the times where low and high tides occur, well, it occurs at the high tides occur at 6 and 18 hours. Low tides occur at 0 to 12 hours, right? And the cycle appears over. The cycle continues over and over again. I explain how the graph of the function you wrote in part A is related to a graph that shows the tide at depth D at port T hours after 3 a.m. So 3 a.m. is really interesting. We have this is at 3 a.m. right? Let's say our graph starts like this, right? This is our new graph, right? I'll just circle in orange. Right, our new graph. That's 3 a.m., but it's actually 0 in our new graph. And then this is 6 in our new graph. And then this is 12 in our new graph. And then this is 18. I might be confusing you even more. In that case, that's what I should be doing, right? So that's our new graph right here. So it starts right here. It starts right here. Right? It starts in the middle. And what graph has that property where it starts in the middle and goes up? It's the sine function. Yeah, it's a sine function. That's correct. So we have that graph, that other graph. Let's say that's d2 of t is actually not going to be negative cosine. It's just going to be sine. So 6.5 sine of pi over 6t plus 10, and that's our graph, right? I should have made it all orange. I'll make it all orange. Okay, so it's 6.5. No, d2 of t is 6.5 sine of pi over 6 t plus 10. That's our function. That's gonna be it for today's episode. Hopefully I did not. Oh, I was 1 minute longer this time. That's not good. I was not supposed to spend that much time on this video. Anyways, if you enjoyed it, press like and share. And I will be going through trigonometric properties in the next chapter, right? And after this series, I might do some other videos that will help prepare you for calculus, because I know that this is not enough to prepare you for calculus. It really isn't. And if you try to go from integrated math 3 to calculus, you'll have a pretty hard time. However, all the stuff from integrated math 3 that you learn should be enough to get you to calculus, provided that you do work and try to get the all the reviews done and all the content, right? However, pre-calculus is just 1 year that solidifies it all together. But pre-calculus does not prepare you for calculus. It really doesn't. Is that enough of my rant about calculus? I don't want to make this video long. So I'll see you next time.